Now exercise 3.2, it is based on two properties. One, that sum of all exterior angles of a polygon is 360. Any polygon, any number of sided polygon you take, and if you consider its exterior angles, extend the sides, then these are called the exterior angles. This, with as many angles they are, they will sum up to give you 360 degrees. This gives you angle about a point. Okay, full rotation is there. Okay, so based on that, another thing, that if it is a regular polygon, you know, regular polygon means all sides are equal. If sides are equal, all interior angles will be equal. Okay, and if you see, interior angle plus exterior angle is always forming a straight line, so that gives you so they are supplementary. Okay, so another property is that for a regular polygon, if I have n sided regular polygon, so sum of the angles will become n into theta if theta is one of the angle. Okay, so n theta should be equal to 360. That means, so from there you'll end up getting those two formulas. It's either theta, if you want to find the angle, will be 360 upon number of sides, or the other way around, if you know the angle, then 360 upon the angle will give you number of sides. Okay, it's just by interchanging their position you get these two formulas. So based on that is this exercise here. So let's take up the first question. You will make the figure yourself, children. It was a simple figure there. So two of the exterior angles were given as 125, 125 each, and one was unknown x. So sum of these three exterior angles should be 360. That's your property. Sum of exterior angles, all exterior angles of a polygon, of any polygon, is always 360 exterior angles if it is. See from the figure, you'll follow it better. So that gives you measure of x as this. Then the B part of that figure I have drawn, because in this one of the exterior angle was not known. So I have named it as A, because first we need to know the exterior angles, only then we can proceed. Okay, so this symbolizes 90 degrees. So the leftover angle A will also be 90, because both of them are forming a straight line. Okay, so 180 minus 90. Now if I know all the exterior angles, then sum of these exterior angles. So 70 plus 90 plus 60 plus 90, this we had worked out, plus x. These are all my exterior angles. Their sum should be equal to 360. So then if you add all these, that comes out to be 310. If you take it to the other side of the equation, it becomes minus 310. So your measure of x has come out to be 50 degrees. Okay. Now, in question number 2, you were told that you have a regular polygon and you had to find the measure of the exterior angle was given to you as 24 degrees and you had to find the number of sides. So, as I said, you just need to know that formula. Okay, that if we know number of sides, then we can find theta as 360 upon number of sides, and if we know angle, we can find n as 360 upon theta. So, in this case, we knew. First case, they were saying that we have 9 sides. So 360 upon 9, we'll know that each angle will be of 40 degrees. Likewise, if there were 15 sides, then 360 upon 15, each measure will come out to be 24 degrees. Okay, so that's the formula you've got to know. Rest is all easy. Then the third question was the other way around, in that angle was known now. Okay, in question number 3, they've given you the angle. They are saying that if each angle measures 24 degrees, then what would be the number of sides? So, as I said, both the formulas are equivalent. So, 360 upon 24, that means n number of sides will be 15. Okay. For the next question here, they had given the interior angle was given to you, not exterior. In the previous question, exterior angle was known, and the property that we have is for exterior angle. Sum of exterior angle is 360. So in this question, interior angle is given to you. You will work out the exterior angle, because we know, as I told you, that in any polygon, interior and exterior put together, they form a straight line here. So interior angle plus exterior angle is equal to 180 degrees. So if I knew the interior angle, so exterior angle will come out to be 360 minus interior angle. This will go to the other side. Okay. So interior angle was 165. So exterior angle comes out to be 15 degrees. And then they were asking you number of sides. So number of sides will be 360 upon theta. Theta we had worked out is 15. So number of sides are coming out to be 24. Okay. Then fifth question is that they had given you a measure that angle is 22 degrees. Is it possible for any polygon to have the exterior angle as 22. So as we know that number of sides is obtained as 360 upon the measure of angle, exterior angle. So 360 upon theta, theta was given to you as 22. When you work this out to find n, n is coming out to be a fraction. N means number of sides. Number of sides cannot be a fraction. It has to be a natural number. 1 side, 2 side, 3 side, 4 side, like that. Okay. So if this is coming out to be a fraction, then that is a contradiction. So we would say that means this angle is not possible. If this angle was possible, then we would have got value of n as a natural number. Then the next part of this was in which they had asked you that this exterior angle is not possible, but is interior angle possible to be 22? So in that case, again, first we'll have to find the exterior angle, which will be supplementary of 22, which is coming out to be 158. And there also, if you try to find your n now, then it is not coming as an integer. Again, it's a fractional value. So you would say even this is not possible. Okay. Then next is a theoretical type of question, question number 6 that we have here, which says, what is the minimum interior angle possible for a regular polygon and why? And what is the maximum exterior angle possible for a regular polygon? Okay, so I've put it in writing out here. I hope if you read through this, you'll follow it properly. See, we know that just try to make few polygons, children. Okay, the smallest polygon possible is a triangle. Then next is a square, then is a pentagon. Okay, all these regular polygons we are talking, all equal sides. So if you go on increasing number of sides, you'll see the angle in between the sides goes on increasing. Okay, so I've written out here that as the number of sides goes on increasing, the measure of the interior angle also increases, right? And because of that, interior angle will be minimum when we have the smallest polygon, and that smallest polygon is regular polygon because we are talking about equilateral triangle, and we know measure of each angle of equilateral triangle is 60. So that is why the minimum angle, interior angle possible for a regular polygon would be 60 degrees, right? And then if you see in a straight line like this, if this is your interior angle, so if interior angle goes on increasing, then its leftover exterior angle will go on decreasing. So when interior will be minimum, exterior will be maximum. So for the second part, if 60 degree is the smallest interior angle possible, its corresponding exterior angle will be the maximum or the biggest exterior angle possible. Also, smaller the interior angle, greater will be its corresponding exterior angle, because they are supplementary of each other. So the maximum exterior angle will be corresponding to the minimum interior angle, which was 60. So the maximum exterior angle is 120. Okay.